Alright gang, we're going to start the next lesson right now. So, the next section is section 1.6, function operations and the composition of functions. This educational experience is brought to you by your captain of combinations. That will be me and Mr. Faust. So today, we're going to take a look at function operations with those functions that we've talked about previously about our parent functions and our library of common functions. So let's begin. The first on the docket is the sum of two functions. It can be written as f plus g of x, which equals f of x plus g of x. All you do is add up your functions. So you can see either notation, either this notation or this notation. That just means you add up the two function values and combine your like terms. Next, we have the difference of two functions. Now, again, this f minus g. You could also do g minus f. That's also acceptable if you write it differently, but this way it's f minus g of x. So you take the f of x function minus the g of x function. Notice the star right there. You must subtract the entire g of x function. That means you must distribute the negative through the entire function and not forget to distribute it to one of the values. That is the most common mistake people make with this. So please, please, please don't do that. Okay, next on the docket is the product of two functions. fg of x. That's just f of x times g of x. Notice there is no multiplication symbol in the middle there. It's just f and g right next to each other. Or you could see it like this. There is no multiplication symbol. You'll see why a little later. And then the quotient of two functions, f divided by g of x, f of x divided by g of x, and noting again that g of x cannot equal 0 over here. This is really important. That will cause us some domain problems. So we do have to talk about domain for these particular functions. So you could have the domain of f of x, you could have the domain of g of x, but this function might have its own special domain altogether. And we'll talk about that, about restricted domains. So, given the two functions up in the corner here, I want to find all four of these. So, first and foremost, f of x. This one right over here, f plus g of x. Let me grab my pen tool over here. Snap that one, we'll do it in black here. Alright, so, that's just f of x plus g of x. Nothing earth-shattering there. F of x is just 2x plus 3. G of x is 6x plus 9. You just combine your like terms. 2x, 6x, make an 8x. 3 plus a 9, make it 12. And you leave it like that. Oh, happy days are here again. Let's do subtraction. F of x, f minus g of x. Now, the trick for this one, and what I highly suggest doing, is why don't you distribute before you do anything crazy here. What I mean by distribute is the following. You've got to distribute the negative. So we get negative 6x minus 9, and we still have the 2x plus the 3. That's going to give me over here, ready for it, negative 4x minus 6. Common mistake is you don't distribute the negative to both of these, and that will be incorrect. fg, now this is just f of x times g of x. Now when we do this, f of x is just 2x plus 3. G of x is just 6x plus 9. Well, this involves some good old-fashioned FOIL action. So first gets me 12x squared, outside gets me 18x. So does inside. Neat. And last gets me 27. You combine your like terms, and you get the following wonderful and glorious function. You can leave it like this. Box it in and you're done. Now, the division here. You just take the f of x function and divide it by the g of x function. Now, you might simply say, hey, we're done here. Well, you need to simplify. Here's what's a little tricky. Look at the bottom portion. I can take a 3 out of that and now look what I've got. I can cancel out here, leaving me with a 1/3. Now, the question I have is, what's my domain? It's all real numbers. Why is that? There's no x left in here. The domain of f of x is all real numbers. I can put any x I want in here. The domain of this is all real numbers. And even when I compose them together, I thought I might have a problem down here because I have an x in my denominator, but it ends up going away. So the domain is all real numbers there. Speaking of things, we look here. Next, composition of functions. Now it looks a little weird. It looks like the word fog of x, or as we say, f of g of x, f of g of x, or f of g of x. You could also, by the way, have good old-fashioned GOF, as some people like to say, which is just, ready for this, g of f of x. You could have either one, and we're going to do both right now. So what does this look like? All right, we have f of g of x and g of f of x. And there are my two f and g functions. So what does that look like? Well, folks, it's a fancy way of saying you work from the inside out. So we have g of x here. We'll just put that into my little equation. No big deal there. I can handle that. So I put it into my equation. So I have f, and what is g of x? X minus 2. I replace g of x with just that value right there. What is g of x? Now, all I'm doing is, this is f of x. There's an x there. There's an x there. I'm replacing everywhere I see an x, I am replacing it with x minus 2. I am throwing the g function everywhere I see an x in the f function, the outside one. The outside one is always eating the inside one. Now this, you got to have a little FOIL action here, because remember, this is the following, in case you forgot. Simplify. Okay. Now we do g of f of x. So the g function now is going to eat my f function. So everywhere in the g function that I saw the letter x, or variable x, I am replacing it with the value for f of x. Now notice there the following fun fact. I keep exponents and I keep coefficients. I am just physically taking the variable out and putting the other variable in, which I get this, x squared minus 1. If you wanted to factor it, you're more than welcome to. You don't really have to at all, but if you did, it's acceptable. Either one's fine. Now, the question I then have is, these two things are not the same. So what does that mean for us? Well, guess what, folks? Here's the note. F of g of x and g of f of x do not have to be the same thing. However, they could be. So, guess what? I'm saying that they don't have to be the same. So if you don't get the same numbers, like the last problem, that's okay. We're all good. As long as you did your work right, they could be different. There's no big deal. We're all right there. They could be the same. So let's take a look at an example here. Okay, so there I go. I have f of x being the cube root of x minus 1, and g of x being x to the third plus 1. So let's compose these functions. So, g of f of x. So, the g function. What's the f of x function? Alright, it's the cube root of x minus 1. Alright, so everywhere in the g function that I saw an x, I replace with this. Well, look what happens. I cube a cube root. It's like undoing it, and the gooey nougaty center right there falls out. minus 1 plus 1. Well, it's just x. That's pretty neat. Nice, simple. X marks the spot. Get it? Anybody? No? Okay, cool. Alright, so f. Now, what's my g function? X to the third plus 1. So everywhere in my f function that I saw the variable x, I'm going to take that out and replace it with this. Alright, so that's just going to be x to the third plus 1 minus 1. That's just the cube root of x to the third, because plus 1 minus 1 equals 0. The cube root of something cubed is just x. Huh. X marks the spot. Yay! See, someone got it. So, they both equaled x. They both ended up equaling the same thing. So, what does that mean? Oh, here we go. When both f of g of x and g of f of x equal x, we have something special. Or the fancy way of saying, look, I'm putting in an x, I'm getting back an x. I'm putting in an x to start off with in my function, I'm getting back an x to start off with. We have something special. And that we will cover next section. To be continued. That's right. Like one of your great TV shows with a cliffhanger ending, this has a cliffhanger ending. It's something special, and we'll get to it next section. And now you are ready to tackle and destroy the homework for section 1.6. Oh, happy days are here again. Good luck and good skill. And thus, good day. I say to you, good day, sir. Good day.